Coffee, a beloved beverage consumed by millions worldwide, is more than just a morning ritual or a quick energy boost. It's a complex interplay of chemistry, physics, and personal preference. While many coffee enthusiasts swear by certain methods or rules for brewing the perfect cup, science offers insights that can help separate fact from fiction and guide us towards creating truly exceptional coffee. The journey to the perfect cup begins with the coffee bean itself. Contrary to popular belief, coffee beans are not actually beans at all, but rather the seeds of coffee plants. The two most widely used coffee plant species, Arabica and Robusta, produce seeds with distinctly different chemical compositions, which ultimately affect the flavor profile of the brewed coffee. The primary compounds that contribute to coffee's flavor can be categorized into four main groups: alkaloids, acids, sugars, and furans. Alkaloids, such as caffeine and trigonelline, are responsible for coffee's bitter taste. Robusta beans typically contain about twice the caffeine of Arabica beans, but less trigonelline, resulting in a more bitter overall flavor. Acids, particularly conic and caffeic acids, along with chlorogenic acid, a combination of the two, contribute to coffee's astringent or sour taste. Robusta beans generally have higher concentrations of these acids compared to Arabica, further accentuating their bitter and astringent qualities. Sucrose, or sugar, plays a crucial role in developing coffee's sweet notes and contributes to the formation of other flavor compounds during roasting. The Maillard reaction, which occurs when amino acids and sugars combine during roasting, is responsible for coffee's characteristic brown color and many of its complex flavors. Arabica beans typically have higher sucrose content than Robusta, leading to more caramel, fruity, or fermented aromas in the final brew. Furans, formed during the roasting process from the breakdown of carbohydrates and unsaturated fatty acids, are primarily responsible for coffee's roasted flavor and malty or sweet notes. Arabica beans generally produce more furans during roasting, resulting in sweeter, nuttier flavors compared to Robusta. Understanding these chemical differences between bean varieties is crucial for selecting the right beans to achieve your desired flavor profile. However, the roasting process also plays a significant role in determining the final taste of your coffee. Contrary to popular belief, the roast level, light, medium, or dark, does not significantly affect the caffeine content of the coffee. While some compounds break down during roasting, caffeine remains relatively stable. The perception that lighter roasts contain more caffeine likely stems from the fact that darker roasted beans lose more mass during the roasting process, becoming less dense. When measuring coffee by volume rather than weight, a scoop of lighter roast beans may contain slightly more coffee, and thus more caffeine, than the same scoop of darker roast beans. Once you've selected your beans and determined your preferred roast level, the next crucial step is the brewing process. From a scientific perspective, brewing coffee involves chemical and physical kinetics, the study of how chemicals react and how things move. The movement of hot water over or through coffee grounds, whether driven by pressure or gravity, is at the heart of all brewing methods. There are three main categories of brewing methods: infusion, decoction, and pressure. Infusion methods, such as pour-over, involve water flowing over coffee grounds and soaking them for a short time before being filtered. These methods typically produce a milder cup of coffee and are well suited for highlighting lighter, fruitier flavors. Decoction methods, like percolator coffee, boil the grounds in hot water before condensing the coffee vapors back into liquid. While this approach extracts compounds from the grounds quickly due to high temperatures, the limited contact time between water and grounds can result in a strong, but potentially bitter cup of coffee. Pressure methods, exemplified by espresso, force hot water through tightly compacted grounds. The combination of different particle sizes in espresso grinds allows for optimal packing, which creates resistance to the pressurized water. This resistance facilitates the transfer of energy from the water to the coffee grounds, extracting more oils and resulting in the deep flavor and creamy texture characteristic of espresso. The quality of water used in brewing also plays a crucial role in the final taste of your coffee. Interestingly, hard water, which contains higher levels of minerals like magnesium and calcium, can actually enhance coffee flavor. These positively charged ions attract the negatively charged electrons in coffee compounds, helping to extract them into the water. Research has shown that magnesium ions, in particular, bind most strongly to coffee compounds, followed by calcium. However, it's important to balance mineral content with sufficient bicarbonate to keep acidic components in check. The grind size of your coffee beans is another critical factor in brewing the perfect cup. While conventional wisdom might suggest that finer grinds lead to stronger coffee due to increased surface area, mathematical models based on fluid dynamics suggest otherwise. The Darcy-Forchheimer law, originally developed to explain water flow through sand, can be applied to coffee brewing to predict how water will flow through grounds of different sizes. If the grind is too fine, water cannot flow through efficiently, leading to over-extraction and bitterness. Conversely, if the grind is too coarse, water flows through too quickly, resulting in under-extraction and a sour taste. Recent research has challenged traditional barista practices, suggesting that using less coffee, 15 grams instead of 20, and grinding it more coarsely can consistently produce better-tasting espresso while reducing waste. Temperature is another crucial variable in coffee brewing. The National Coffee Association recommends water temperatures between 90 and 96 degrees Celsius, 195 to 205 degrees Fahrenheit, for optimal extraction. At higher temperatures, water molecules have more energy and interact more with coffee grounds, leading to increased extraction of flavor compounds. Some compounds like koenic, malic, and citric acids are highly soluble and extract quickly regardless of temperature. However, other compounds, particularly those responsible for bitter tastes, are more temperature dependent. Hotter water tends to extract more of these bitter compounds, as well as compounds like pyrazines that contribute earthy or burnt flavors. Interestingly, the perception of sourness in coffee can be influenced by temperature as well. While sour compounds extract regardless of temperature, the presence of more bitter compounds, extracted at higher temperatures, can enhance the perceived sourness through an additive effect. Cold brew coffee presents a unique case where time, rather than temperature, is the primary factor in extraction. The cool water used in cold brewing slowly extracts flavor compounds over an extended period. Some compounds, including chlorogenic acids and trigonelline, leach out much more slowly in cold water, resulting in a generally sweeter and less acidic brew compared to hot brewing methods. In conclusion, the science of brewing the perfect cup of coffee is a complex interplay of numerous variables, from bean selection and roasting to grinding, water quality, brewing method, and temperature. While these scientific insights can guide us towards creating exceptional coffee, it's important to remember that personal preference plays a significant role. The perfect cup of coffee is ultimately the one that you enjoy the most. By understanding the science behind coffee brewing, enthusiasts can experiment with different variables to fine-tune their brewing process and discover new flavor profiles. Whether you prefer a bright, fruity pour-over or a rich, creamy espresso, the principles of coffee science can help you achieve consistency and quality in your daily brew. So the next time you prepare your morning coffee, consider the intricate dance of chemistry and physics happening in your cup, and appreciate the artistry and science that go into creating this beloved beverage.